I'm Walter Grayman, representing the WDSA History Project. The purpose of this project is to document the history of water distribution system analysis and to disseminate this information through the American Society of Civil Engineers Environmental and Water Resources Institute, EWRI. A multimedia format is planned that will include both traditional text and a variety of digital material. An important part of this project is a series of interviews with engineers, modelers, researchers, and practitioners who have made significant contributions to the field of water distribution system analysis. Our interview today is with Dr. Richard Mayles. Richard is a consultant in the area of computer applications, primarily in the field of water, and president of RMM Technical Services, Inc. in Cincinnati, Ohio. During the 1980s and into the 1990s, Dick was very active in the development and research related to water distribution system analysis. As a consultant to US EPA, working with Dr. Robert Clark, he developed the first steady-state water quality modeling software for distribution systems, pioneered the concept of integrating distribution system models and databases, and applied diverse technologies such as expert systems and graph theory in this field. This interview is being conducted on February 4th, 2015 in Cincinnati. Dick, how did you first become involved in research in the area of water distribution system analysis?
Thank you very much, Walter, for this opportunity to reflect on work done many years ago that has been quite enjoyable, and particularly the chance to go back and look at some old documents and reports and think about how much fun we had at those times. The way that I got started in this work was a project in 1978 working for Robert Clark at US EPA entitled Evaluation of the Hydraulic Module of the Water Supply Simulation Model. At that time, I was working for a company, W.E. Gates & Associates, located in Batavia, Ohio, and we had worked previously on other projects for EPA in terms of various kinds of mathematical modeling. So we had some relationship with EPA here in Cincinnati. Bob at that time was doing work on cost of water distribution systems, very early revolutionary work in which he was working with a gentleman named Richard Stevie, an economist, to look at how costs varied spatially. And in so doing, they were using a proprietary hydraulic model, I believe from the University of Waterloo, although I'm not sure, as part of their conceptual analysis of costs of delivery in a transmission system. And one of the things that struck me early on here was that they were showing a map of the relative cost of water delivered to different parts of the distribution system. And as we all know, people pay the same amount independent of where they are. It's only done by volume. But Bob was pointing out that depending on if you're at the top of the hill, the bottom of the hill, far from the plant, close to the plant, that you will, the utility will incur different costs in getting that water to you. So there are subsidies in various parts of the system. Some people are paying less than the actual cost. Some people are paying more than the actual cost. So one of the things that he wanted to do was have an external review of the hydraulic water distribution system model to see how it was behaving, and we at the company got the opportunity to do that work, and I was the one who was tasked with being the project manager on that.
You mentioned the water supply simulation model, WSSM, that integrated distribution system models with a database and various analysis and display routines. This is a very widely used project today, but quite revolutionary 30 years ago. Can you talk about how this concept evolved and its implementation, and how it contributed to this the integration process?
Well, Bob had already developed the concept of the water supply simulation model as an integrated an examination of things. By way of a little background and full disclosure, Walter, you and I have worked together on a whole lot of these projects, and our relationship dates back to sharing an office in graduate school in 1967. So in the company Gates and Associates we were working for at the time, we had been working on a system that integrated geographic data and models called ADAPT, Aerial Design and Planning Tool. And that system was a large computer system, and I remember full well at that time going to the computer center with large decks of cards that represented all of the data that we wanted to use. So as a part of an evolution of that, we went to a database concept that would put things on what are called, at that time, direct access disks, rotating memory on the large computer. And so in the context of the ADAPT system, we had the idea of an underlying database that was just there and available, and you could run programs that read and wrote to that database. So we had that concept firmly in mind by work that we had done starting roughly in 1973. So by the time we got to working on the water supply simulation model, the idea of incorporating that concept was very, very familiar to us, and we had the resources, we had the people in our group who could implement that. So primarily that was implemented in terms of the link file and the node file that described the network system. And we had spatial locations of these things so we could get plots, because again, our prior work had predisposed us to thinking of things in terms of spatial plots and geographic plots, plus the work that Bob did, which was in a hand process showing those contours of costs.
In the mid-1980s, you were principal investigator on a cooperative agreement that EPA had with the North Penn Water Authority in Pennsylvania. And for me, it was the second project that I worked on when I first went out as a independent consultant. I did appreciate that. Can you provide some of your thoughts on that project and some of the people that were involved in the project?
Well, I left the company where we'd done the initial work on the water supply simulation model in 1982, September of 1982. As I recall, you left that same company some 9 months later. One of my first jobs was, again, for Bob Clark, and let me just take a moment to say how instrumental Bob was at that time and throughout 20 years in terms of sponsoring the needed research to make really dramatic advancements in the field, and give him a little shout out for the generosity that he had towards providing this in a research context and disseminating this information very, 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 very widely. So the first project was familiar with Bob for the previous work on WSSM, and we had also done some work in taking that out and testing the database concept and the modeling concept in Tampa, Florida, Kenton County, Kentucky, and New Vienna, Ohio, where we were demonstrating graphics and modeling that all were attached to the database. So Bob, I think, had some prior relationships with North Penn Water Authority. They, under the leadership of Harry Borchers, were again a forward-looking agency located in Lansdale, Pennsylvania, north of Philadelphia. Small system, a lot of wells, And they were interested in participating and looking at the issues of water quality from their various wells. So we started down that road. I got the contract, and then when Walter became available to do work, it was certainly a wonderful thing to have him involved on various aspects of the modeling. We also involved Tom Walsky at that time to do some studies, and we shifted our modeling software, which had gone from the original proprietary model to a WattSim model that we obtained from, as part of the WSSM, that we obtained from the Denver Water Board, and then onto the WDSA model that Tom Walsky had developed with the Corps of Engineers. We worked for North Penn for a number of years, doing all kinds of interesting work. Probably the most significant work that came out of that was the development by you, Walter, of the dynamic water quality model, which the prior work that had been done was used steady state modeling. And we had published in 1985 an ASCE paper that described algorithms for, with the availability of a steady state hydraulic solution, that would give you a solution to the cost of delivering water to a given point, the travel time of getting water to a given point, and the mixing of water from multiple sources. So that was an interesting paper that was worked on early on in the 80s, and but it was not adequate to the real world of dynamic systems. Also at that time, as I recall, the world of water distribution systems modeling was moving from steady state to what they called extended period simulation, which is a series of steady state snapshots, and then further on to a full, truly dynamic water model. And so we were working in that context, and then using North Penn to develop the idea of the dynamic water quality model, which led to basically a revolution in the field.
In your work, you have always tried to introduce emerging technologies from other fields into your projects. As part of the North Penn project, you did a mini study on application of expert systems to the customer complaint process. Can you tell us a little bit about that?
That was particularly interesting. If you recall, at that time, there was a great deal of interest and ferment in artificial intelligence, AI, and expert systems were being touted as the thing that would replace humans in all kinds of decision-making capacities. So there were lots and lots of things out there, examples. So again, under Bob's guidance and willingness to go down various paths and explore interesting things, the idea was to take a look at this, and we had a good relationship with the people in the North Penn Water Authority. So in talking to them, the idea of handling customer complaints via an expert system was brought up, and we implemented a prototype model of this. The general concept was to see if it was possible to offload the incoming telephone calls about water quality complaints not to the lab manager at that time, Judy Coyle, but to administrative staff who could use the expert system that incorporated the expertise and decision rules that Judy would use to decide what to do, to at least take the first step in giving information to customers and recording their complaints in a database. It was a very interesting study. It was research, and it was written up as really a cover article in the AWWA Journal. It never got put into practice. Changes at the the North Penn Water Authority resulted in sort of a lack of continued interest in this, and we did publish the document about the work, but it just really, it turned out that it wasn't so much the rules and the expert system that was of interest, but the kinds of things that are quite common today of recording things right into a database and sending things out automatically or making them available on a web page. So it never got fully implemented.
As a follow-on to the North Penn project, you worked on an EPA-sponsored cooperative agreement with the University of Michigan for the application and development of various water distribution modeling and analysis tools in New Haven. The principal investigator for the University of Michigan was Rolf Deininger. Rolf passed away a few years ago, so we can't interview him. Can you share some of your experiences and thoughts about Rolf and that project?
Well, Rolf, as anybody who knew him will attest, was a larger-than-life figure, always excited about something, always going down some pathway and some road that was new and interesting. And in that capacity, he had developed a relationship with Bob Clark at EPA, and that was an ongoing relationship for quite a while before I actually met him, in which he was introducing microcomputer concepts into EPA. He was a very, very strong believer that this was the wave of the future, and through his contract he was able to place microcomputers into EPA and train and get people to use them. Insofar as I think the first time I ever saw an Apple Lisa computer was something that Rolf acquired and brought into EPA to show the capabilities of that kind of technology. I had a long relationship with him over many years, and just a lot of fun. Traveled with him internationally on projects, and a great guy with all kinds of interesting ideas, and a serious loss that he's no longer with us.
I second that. In 1991, you and I were co-organizers of a workshop sponsored by EPA and what was then the AWWA Research Foundation on water quality modeling and distribution systems. This was a field that was just emerging at that time. Will you share some of your recollections of the workshop and its impacts on the field?
Well, again, the first thing I'd like to say about that is that it was done under the auspices of Bob, and the idea that you, Walter, and Bob and I all shared was that we would be better off cooperatively sharing ideas. And this was really one of the first opportunities to bring together most of the people who have been working in this field internationally. And so that was really a great opportunity. It was 2 or 3 days of presentations and the opportunity to interchange ideas here in Cincinnati. But again, the main thing that occurs to me here is just this general idea of it's important to put this stuff out there in the world. It's important to share ideas. I think this was well before commercialization of software of this kind started to become important, and people were questioning what EPA should or should not be doing in that regard. So we had an opportunity, a window of time, to talk to many of the distinguished people, Don Wood and Ori Shamir and many others, about what was going on in this field. I put a paper in. I was an organizer, as was you, so I didn't have a whole lot of time to prepare a paper, but I did put something together that, one of my regrets, professional regrets, never really went anywhere. And this was the idea of looking at water resource networks as graphs and seeing if there was anything that you could learn from them just by looking at their characteristics, measures of that can be applied from graph theory, which would give you an idea perhaps of resilience, robustness, things like that. But that seems to not have gone anywhere. So be it.
I have a picture that was taken of all the participants. There was about 40 people at the conference, and it's quite significant when you look at the number of people who were attending there who have since gone on to become very important contributors to this field. Are there any other thoughts about your work in water distribution system analysis and how the field has changed since your primary involvement almost a quarter of a century ago?
Well, a couple of things. I stopped basically in the early 90s. My professional path went in other directions, but occasionally I've returned to it and had the opportunity to see what's going on. Now, as I discussed earlier, a lot of it has been in the context of large-scale commercial software, integration with GIS, integration with SCADA. One of the things that I think, again, going back to the influence of Bob Clark and his group, was the support for the development of EPANet and the willingness to put that out there in the world, and just how significant that is and has become. For the rest, not being deeply into this, I will confess to being a little skeptical of some of the claims that are currently being made for the wonders of distribution system modeling and integration with SCADA and real-time control. I think that they may be the flavor of the moment right now, but I think that water distribution systems are extremely complicated, and until such time as there is sort of complete smart networks out there with detailed monitoring, some of that may be proved to be overblown. And again, the commercialization somewhat concerns me, because that's a matter that we tried very hard to put our stuff out there as public domain software. One other thing, of course, since 9/11, much of the attention focused on water distribution systems has been on security issues. It looks like right now there are some other terrorist attacks, things like that. It looks like right now that's changing a little bit, so that there's an opportunity to look at other aspects of it without all the focus being on security issues.
Thank you very much for taking the time to share your thoughts on this topic.
Thank you, Walter. It's been a lot of fun to look back.